Cash, so we're gonna do cash or number 8 together.
N equals 8, not number 8.
And, oh, the n equals 8 one? Okay, we can do that. Not number 8, so n is 8. Okay. So, yeah, let's look at this together. So, we have, so this is 7, and then we're doing n equals 8. So, we have g of x from 2 to 6, but they want n is 8, so that means that if you're unsure on how that helps us, it's actually kind of a useful thing. We do 6 minus 2, and n is 8, so we get 1/2 as our h, right? Because it's 4 over 8, which means that that's how much we're going up by. So that's what we're going to make our table. So we start at 2, and then we go 2.5 because of this. 3, 3.5, 4, 4.5, 5, 5.5, and then 6. And so we have to figure out all of our values throughout the way. Now, what probably is an issue is you can totally miss, like, sorry, you can make a mistake, like, I don't remember who was talking to me about it, like, I think they were doing -8 on this step. So just like a silly mistake, they translated some number wrong, and then like all of your decimals are wrong. So kind of watching out for that and being careful as you go here, kind of being like looking at the numbers and deciding do they make sense. So we have to put all these in. And so I'll start doing that. I think, as long as or like forgetting the -2 or something silly like that. Let me know if you guys noticed something that I did wrong too, like. But.
You're like sick every day after school. So then how would I just be there. So I basically they are manager. Well, I don't like when you just make Friday do it all. And just so you can be there. And then get paid at the end of the year. How much you paid? I don't know, I paid like probably like but
Cash, are you finding your mistake in the table?
Wait, did we just do 2.5? It still looks like it's
well, I don't see left to get
What's that?
you'll get a single digit answer because it's more than
If I want the whole number, I got a single digit answer? Because I think it's an even number that we end up with for. Are you checking the table while I was asking? Does your table look good so far?
man's literally doesn't do anything I try to do.
We're gonna do the right endpoint, so we are gonna throw that one out. So okay. So for the right endpoint, we're gonna take all of the ones on like basically the right side of the table and add them together, and then we can't forget about the h value. So you have to take that h value and multiply it to those numbers. I would suggest multiplying at the end, makes it a little bit easier to do. So I add all those first and then take half of it. because of the h. Now again, I told you guys, once you guys started going on number 16, I said you didn't have to keep going with it, but if you did, it's the same idea, but what we're doing is we're approaching a more exact answer. So as we get more and more rectangles, we're getting closer and closer to the actual answer. So I believe I got 362. I'm gonna have to do half of that.
No, it was numbers n equals 16 usually the digit answer.
So that's where we get the 181 from. All right, questions there? So, again, we're still going to kind of keep doing baby steps here as we go into break. Our lesson today is not very long, but it's definitely something you guys haven't seen before.
Basically, yeah. And like, like the good side, we're just like basically spot drilling. So like we're just gonna move, but like if we're not like going by, basically he like yells at us. And it's
That would suck.
it's for like 15 minutes straight. And then the kids on the other side just do like normal drilling, but they like talk for like 20 minutes.
Oh, you have that. Oh, I never stamped your assignments, guys. I'll just go with what you guys have. How about that?
You have to stand there.
Yeah, you have to send my phone.
What do you need?
You have to send my phone.
Oh, it was on your phone.
Can you take a picture of it?
Oh.
Because
It's not very nice.
What do you need?
how do you forget you're going to school? How do you forget school stuff?
I was late this morning. You're supposed to think about it.
Workout should work out. We are wrestling doing free workout.
Yeah, I'm in basketball, so.
Yeah.
I did run like 3 miles yesterday.
Yeah, you guys had a lot of conditions. Kate came home and I was like, how was practice? Because she's so tired.
Jaden Cox says the best conditioning for a sport is playing a sport. That's true. That's facts.
Conditioning was not fun.
Well, actually, he didn't say that. He said the only way to condition yourself for wrestling is by wrestling.
That's true.
Because he says like you can run all you want and it's like you're still gonna get gas in wrestling. It's good for wrestling. I was there when he said that. I was there when he made it cool. I was like, practically in his face. I could touch him.
Where were you?
Korean. He was there.
Did you touch it?
Yeah. He drilled a move on me. I never showered it since.
You remember what?
I started on two places.
Okay.
I was gonna go somewhere better. Let's just do that.
And if you can't read that, that's supposed to be a 60-degree angle in there. So we're gonna talk about a couple of different areas today as our warm-up. And this is intentional. Oh, that should be section, I didn't change the
It's
title.
12, 21, 21.
Oh my gosh.
So that's all ones and two. I don't think that's like a.
Yeah, it's not a, but no, I still, yeah, nice set of numbers there. I realized I didn't change the title of the section. So we're technically now in section 9.5, I believe. And change the title. Oh no, not 9. We're in chapter 13, how about? And I believe it's 13.3, sorry, I'm all confused. I can't believe Christmas is this.
We just go sharp with this, huh?
You're later.
But pencil sharp is it?
Oh.
All right, so we talked about this a little bit the other day, that sometimes our area under the curve is going to look a little more like a trapezoid. And so finding that area is something that we want to know how to do so that we can find the best area underneath the curve. Same thing's going to happen is there's going to be times that the area might look like a sector, so part of a circle. So remembering how to find the areas for each of these is something we're going to talk about. Now, these are two formulas you might not remember the area of. I actually, as I was doing this last night, I had forgotten like a major part of the area for the first one, and we'll talk about that formula for each of these. So if you forgot, it's okay. It's over here. Hi.
Are these in notes?
I saw initially that you were out, and I was like having a moment of freak out. All right.
Come on. Must be nice. Yeah, it must be
Maybe we
nice.
should send some sponsor food.
Yeah, well,
These are nice.
gee, why do you have to do it like that? No, you gotta look at me like that. That's like threatening.
Call them.
We feel threatened by that as looks.
Yeah.
So these are our two formulas for area of a trapezoid and area of a sector. So if you want to take a minute to find those areas.
What's B1 and B2?
What is B1 and B2 in a trapezoid? Do you guys know?
Base 1 and base 2.
Yeah, the bases.
Top and bottom.
And the bases, yeah, are essentially the sides that are parallel. Are there any calculators in there? Yeah. I feel like I'm low on calculators, so if you guys happen to
Is
see one of mine,
Why'd
some,
you cover these?
is X the
that's
degree?
my freshmen or sophomores. I didn't realize.
Is X the degree?
Yeah, X is the angle.
They get
Yeah, see, stupid sophomores, come on.
Yeah, I hate
Imagine
those
being a
guys.
sophomore.
This guy's soft. She said freshman.
She said-
It was, I changed my mind. It was
Yeah,
sophomore
that's
boys.
messed up.
Yeah.
And it was boys. So
Yeah, imagine being a sophomore.
Yeah. Yeah, we're both soft. Can't imagine.
They were back there, and I didn't realize what they were up to. Shows how clearly I was watching yesterday afternoon. All right.
This thing. It's big.
Now, the h is the height, and that's always perpendicular with the bases. So the height in this case would be 4. And you have to follow order operations. So base 1 and base 2 actually get added first because they're in kind of a grouping symbol with that division bar. Now, if you ever absolutely forget the area of a trapezoid formula, like on an ACT or something like that, you can usually break a trapezoid into a triangle and a rectangle, or two triangles and rectangles. It just depends if they've given you enough information to figure it out. So our area in this case is going to end up being a decimal. So this is 13 over 2 times 4, right? Oh no. The 4 is because the 4 will cancel with it, right? So 26 square meters. And then, yeah, the area of a sector, I can't remember, when we was doing this, did we do this in trig and not this class?
Yeah.
Must not have done. I remember teaching this not that long ago, but it must have been in trig.
sorry. Highlight when I'm not in 6, it should be.
8, thank you.
Gee, just trying to
Well,
work.
I looked at it and I was like, where did you get the 6 from?
Yeah, no, it's fine. I'd rather her say something then.
But she sounded like a child.
She sounded like a jerk.
That was definitely a personal thing.
Yeah, so that was
You're
like,
throwing shot. You're smart.
yeah.
Oh my
Do you
god.
need to take a break, Pepper?
Maybe.
Been here all of 5
According to
minutes.
you guys, I do.
Yeah.
Yeah, you do.
I hurt somebody's feelings, you probably already did.
Yeah. Maybe it's not you.
Maybe I should be the one that takes the break. I'll be out of here.
Well, then we're stuck.
That's true. She's gonna start punching us.
Maybe I'll take a walk and she can stay here.
Take him down.
Nope.
While you guys are playing, who's money?
Alright, so now this is going to be a decimal, partly because of the pi, partly because of just the numbers themselves. So this is going to be about 33.5-ish, and they don't have units on this one. Now you'll also see the book sometimes write this as just a simplified fraction with the pi left in the answer, so like the answer key might write it. So they have 3840. You can cross those zeros out. So I'm just trying to show you guys another way that they might write it. So they would divide those each by 12, I think. So you might see the book write the answer something like this, but this is essentially the same thing. So just that you guys know, if you see a different answer, just kind of multiply or check it and see if it's the same. So again, I didn't like just pull these warm-ups out of completely nowhere. I chose these because we'll have to be able to find the areas with those two anyhow, or with like those two types as we go today. So we've been doing, like we've been calling them left hand and right hand endpoints. We're going to talk about today like an upper sum and a lower sum. We're not really going to use that all that much, but I was getting into that yesterday in our notes where sometimes the graph, the rectangles are above the graph and then sometimes they're under. So what we're trying to find is the middle ground between that. We're trying to find how close we can get to actually finding the exact answer. So the upper sum is the estimate that's too high. So if I have a curve like this, our estimate that's too high is the one that goes over the top of it. And then the lower is the estimate that's obviously too low. So again, if we're talking about this same situation, what we're trying to find is like the average between these two, or the middle ground. We're trying to get them closer and closer. We talked about having more rectangles getting us closer and closer. So what we're going to talk, like basically finding that middle ground is the actual answer. Now one of the things we also learned, and you guys saw that when you did like if you did the n equals 16 thing, is the more and more rectangles you have, the closer and closer we get to the actual answer. So as n, the rectangles increase. The upper and lower estimates or limits get closer and closer to each other. And that's kind of the idea of a limit. We talked about limits earlier in the year. So as a number approaches, or I guess we just talked about last time, as like h approaches 0. So as we approach, like as n gets bigger, as n approaches infinity, we get closer and closer to the actual answer. And sometimes we never quite actually find it, but we get closer and closer. So we're going to use this thing called definite integrals. And this is where it starts really looking like calculus. So you can look like a real calculus person when you start writing these. So it looks like an S that's kind of like been pulled apart, like kind of dragged. And I'm going to kind of write what this looks like in general here. And I'll explain what everything stands for. So the integral from A to B. And so again, it's supposed to look like a stretched out S. So I'll explain what some of these things mean. So that S shape is supposed to look like an S because it's supposed to make you think about the sums. But it's what we call our limit of sums. So again, it's as we're getting closer and closer to having our two estimates come together. So our upper and lower. The A to B is the same we've been talking about. So we basically say this is an integral from A to B. And those aren't anything new, that's like our range of values we're going to work with. The new thing also, obviously f of x is the function. dx looks new to you guys, probably. And this is trying to tell you what we're working with, that x is our independent variable, x is the value that we keep changing. So x is, so I'm going to write it that way, x is independent variable. So what they mean by independent variable, if you forget what that means, is that's the one we get to choose. That's the one that kind of keeps changing and we choose and it impacts the function. So that's the one we're dealing with in this problem. So these first couple look absolutely awful, and all we're doing is just writing it out, like what's going on in the situation. We're not actually going to solve it. So these look scary to begin with, but they're really not bad. On the back side, we'll get there, but we have some work to do with that. So like that'll take a little bit longer, but they're not difficult. Again, the warm-up question is going to be helpful for us, so hopefully that'll help. So it says express the area using our definite integral. And I had a shade, there was supposed to be shading on here, but it didn't show up, so I colored it, and it should have colored it on your part too. So if we're trying to find this area under this curve, again, we're going to use our notation here. What's our range of values? What's our A to our B? 2 to 5. It goes from 2 to 5. That's the width of this. So I write 2 to 5. Want me to restart it? Thanks. It's really loud. All right. So the function in this case, they give it to us. It's this function. So I'm going to write this as the function here in our equation. Now again, this function looks awful, but we don't really have to do anything with it. We're not solving it right now. And then I just put the dx on the end because that's the variable they're dealing with. If they were dealing with t, we'd put dt. It just happens to be the variable that we used. And on these problems, that's all they want you to do, is just understand what it looks like. So that's all done. So again, same thing on this one. You're basically trying to explain how high to low it goes. So this one goes, it's from 1 to 4, right? And so kind of trying to show you guys the different types of functions here. It could be a square root function, it could be absolute value function. It doesn't really matter the type of function. We're still trying to find that area under the curve. And this is again where our warm-up's coming into play. If you look at this, this kind of looks a little like a trapezoid there that's under that curve. That's a better estimate than a rectangle. So if we can use that, we're going to try and use those shapes that we're familiar with. All right, I think we'll just keep working, and if you guys want, I do, like if you want to do like a fun Kahoot or something at the end, we can. Otherwise, if you just want to keep working, we'll just keep going here. I plan on Thursday not being any new learning. We might do some I might try to find some logic puzzles or something fun. But also, yeah, we can do some other things. So I didn't want to learn something brand new on Thursday. That's okay.
That's amazing.
So we haven't had a day off, but at the same time, sometimes days off are just kind of strange because we don't know what to do with them. So we'll figure it out. But all right, so we're going to talk about the exact value of these sums or these integrals. Now this probably feels like we're talking like a whole different language. So what the equation here is y equals 4. Does that make sense? Because that's the function there. So if I'm going to put this on a graph so you guys can kind of see what I'm talking about here. And it doesn't need to be a perfect graph. I'm just trying to show you guys what's going on. Y equals 4 is a flat line at 4. But where am I looking for this situation to occur? Like what part do I care about?
5 and 2.
From 2 to 5 in our x value. So this is the y, here's our x, so from 2 to 5. So this is what I want to find the area of. Do you guys know how to find the area of that shape? So that's a shape that shouldn't scare you. We can find the area of that under the curve. In this case, the curve's not very difficult. That's just a rectangle. We're just going to find that area. So it is 3 wide. You're talking about spaces, yep.
Is there a way to find the area without drawing a graph or no?
I think until you can totally visualize it, at this point, no. There might be some formulas that can help us with it. But something like this, if you can visualize it, yeah, I'm a visual, I need to write, I need to see it. So there's going to be some formulas and stuff that can help us eventually. But actually, we could do it without. Let's talk about it in a second here. So 3 times 4 is our area, so the integral is going to be equal to 12. What we basically could do, we could do a table, might be another way to do it, is that it's like the space, thinking about from 2 to 5, how many spaces there would be, and each one would be 4, and so there'd be 3 groups of 4, so you probably don't necessarily have to graph something that straightforward. From 2 to 3 would be 4, from 3 to 4 would be 4, and then 4 to 5. So you can probably kind of reason through it. But we're going to see some that are probably a little bit more that you need to see the graph. So this one, the equation is y equals x. Now this one's a little bit more complicated because it has a negative. So our y equals x graph, what does that graph look like? Straight line, going right to the origin. So I basically can graph this by going 0, 0, going right to the origin here. But I want to find it from -1 to 3. So -1 is over here. See that little section, and then 3 is here. It's me that little section. So I have two different areas I have to deal with. What formula are we going to use in this case?
Circle.
You say circle?
Yeah, because it's like degrees, like around.
Oh, I see what you're saying, but no, it's not a shape. The area, a triangle. Do you see that that's a triangle?
Well, yeah, I know, I see the triangle, but over here there's a triangle too.
Yeah, but that's a circular triangle. We'll get to that one. He wanted it to be like a warm-up, but yes. It doesn't have a curve on the outside. We'll get to, there'll be one like that, sorry. All right, so half base times height is the area formula we're gonna use. Now, the one over here is pretty straightforward. The one down here, what do you think we need to call the area in that case? It's going to be a negative area over there because it's down underneath the axis. So this one's going to be positive up here, and this one is actually going to be negative. We're actually going to kind of take it away. So this is 3 wide by 3 tall. That's my little area there. So the first one is going to be half 3 times 3. But then I'm going to subtract off, or I guess you're adding it, but it's a -1. So this is going to be 4.5 minus 0.5. Area ends up being 4. So the dx is just trying to tell you that that's the variable you're using. That's my only explanation for why it's there. It's just an extra. They just want something fancy on the end. I don't know. Because I think there's going to be times that more is going to be happening with that as this gets more complicated. It could have more than one d there. And so like right now it's pretty, we're talking about the variable x. So yeah, kind of right now you can kind of ignore it. We're not going to have something different there right now.
Okay.
It's just getting used to that notation. All right. I would say letter D is a little bit easier. So why don't we go there first? Let me give you guys a little bit of